Hello and welcome to module number 4. In this module, we will explore different aspects of iOS development and the app development process. The context of this module is a music learning game. So we are learning about how to build a game. By this, I mean the components of a game, not necessarily the interface and the animation and so on and so forth. So we will learn about the concept of a game and what components should exist in a game, and we will also explore music and learning, teaching the user how to teaching or quizzing the user for the learning. The app we want to build is an app to teach music notes, and the specific problem statement, or not problems, the initial statement is to develop an app that trains a person on recognizing music notes. This is, as we mentioned before, a vague statement, usually one sentence, that if you're building the app for yourself, it's an idea that comes to your mind. If someone is talking to you about this, then they will share with you that initial sentence that they came up with. And the app development process is the steps you follow to go from this one sentence until you have a fully functioning app that you can deploy to the store or to the user. To review quickly the app development process, there are three primary steps: problem formulation, solution formulation, and solution implementation. In the problem formulation, we do some research, identify the scope of the app, how are we going to test it. In the solution formulation, we follow the model view controller design pattern. So we ask questions about the model or the data that the app will need or interact with, the view, what the user will see, and the controller, the logic that the app needs to process. Then the solution implementation step, that's the project management step, that the action plan, taking those ideas and actually executing them. And in the solution implementation, we follow the iterative development life cycle. Specific questions, as you can see under each one of those, and we applied them in the previous three modules and will continue to apply them in this module. What you can think about is that in the iterative development cycle, we have multiple iterations. Within each iteration, we follow these steps. So let's apply to the initial problem that we have. Again, this is to develop an app that trains a person on recognizing music notes. So applying step number 1, problem formulation, doing some research. So what research we need to do? Two types of research. First research, are there other apps in the market that does something similar to this? And we find this through the iTunes store. So you open the iTunes store and search for keywords related to this. So music learning, teach music notes, or something like that, and see what's out there in the market. When you see what's in the market, you try to identify, as we did in a previous project, and I'm not doing it in every single project. I did it in, I think, module number 1. So you follow that on your own. Identify what features those apps have, what features are missing, how the interface, look at what the users liked, what the users didn't like, and try to gain an understanding of that environment, that context of music learning, for instance, in this particular project, and what is missing. If you're able to identify something that nobody else has, or an approach that different from others, or at least you could be similar to others but come in with something that's maybe better, more efficient, more friendly, has more logic, and so on and so forth. So spend some time to research what else exists in the market. Then the second type of research is gaining a better understanding of the problem. Some of you may be musicians, so you understand what music notes are and how people deal with them, and maybe this is new to you, so you spend some time learning about that. Also, maybe you're a gamer, you have a very good understanding of the components of a game, Or maybe this is the first time, so you don't really know what constitutes a game. So you'd spend some time learning about that. We call this contextual research. You understand the context in which you are building your app, and previously the market research, understanding the market to which you're going to present your app. So in creating a game, there are several components. Um, a challenge. So every game has a challenge, a problem. Whether this is a role playing game, a text based game, or an animated game or a video game, there is a challenge. You need to answer a question, you need to pose a question, you need to overcome a physical challenge or something like that. So there is a challenge. And the way to present the challenge to the user. So in a text game, you present the challenge in a text. Maybe you present it in an audio, in a video. Maybe you present it through an obstacle course. Maybe you present it dynamically, and so on. So there is a way to present the challenge to the user. Then there is a way to collect the user response. In a text game, maybe you give the user the keyboard, maybe they will click using the mouse, maybe they will use a joystick to respond to the challenge that you give them, or whatever other means that you're gonna be very innovative about. And as if you play game, there are so many different ways for the game to get back the user response to the challenge. And then finally evaluating the user response. So in a car racing game, for instance, you're providing the challenge in the form of a road that is moving on the screen, and the user need to respond to that challenge by turning the car to avoid the obstacles on the road. And as the user turn the car, you collect that response through the location of the car based on the turning angle, and then evaluate if the user turned it to avoid the obstacle, then the user keep going. If the user hit the obstacle, then you either deducted a score or take out lives or whatever it is that you're doing with the user. In a simple text game, you present a question, the user answer the question by clicking or typing or speaking or something like that. You evaluate that response and make a score or something of that sort. So a game must have a challenge, a way to present the challenge to the user, a way to collect the response from the user, and a way to evaluate that response, which means that how are you calculating the score? What formula are you using to calculate the score? As the user has sometimes the user gets only one chance, sometimes they get multiple chances, and so on and so forth. The Once you have a context of a game, for instance, in this case, we have music learning, that is the context, you can formulate many different types of challenges within that context. And even within the same challenge, you can have different ways to present that challenge to the user, different ways to collect the response, and different ways to evaluate the user response. So there is a lot of areas of innovation, new ideas, customization, your own design choices when it comes to what you want to do with the game. So even though I'm providing a context and I'm going to make in this module very specific decisions on what the challenge will be, how to present the challenge to the user, how to collect the response, and how to evaluate. However, you can feel free to play around with those design decisions and create a game that is either similar or a little bit different. There are, if you are in my class, there are specific things you need to complete. If not, then you have a lot more freedom. Even in the class, there's a lot more freedom to explore and do extra credits or additional components for the game. Uh, but the key I want you to leave this conversation with is a game has specific components. You can have different varieties with these components even within the same game context. So once you have an idea for a game, like I want to teach people how to recognize music notes, you can, from this one context, come up with 4 or 5 different variations of games. So you can make 4 or 5 games out of that one context. Or maybe you can have different levels within a game based on that one context and one idea. So in the research here, we're going to challenge the user to recognize and identify music notes. Um, and how are we going to present the challenge to the user? We're going to play a sound to the user, the note, played by a guitar, and then the user will hear it. So the user will hear the sound. That's the way we're gonna present the challenge to the user, and we're gonna give the user multiple turns. So we're gonna have them within the game, have them listen to more than one sound and collect the response for each individual sound. So how are we going to collect the response to the challenge? The user will need to select by clicking a button the name of the note that they heard. So if they heard the sound, they think this is the A note, then they click a button saying, oh, this is an A note or a B note or a C note or whatever it is like that. Then we're going to evaluate the user's response. We're going to check when the user clicks a button to say, I think this is A note, we're going to see if this was really the A note that was played. So we're going to take the name of the note that we played for the user and the name of the note that the user think it is, and we're going to compare them. If the user answered correctly, we're going to give them a score. If the user did not answer correctly, in my context here, I am not deducting from the score. So as I mentioned before, I am making very specific and design answers to these questions. You can, when you create a game, there might be other answers as well. So for the score, I'm going with a very simple formula for the score: the number of correct answers divided by the number of turns. So I mentioned when presenting the challenge to the user, we're going to have the user listen to more than one note, the sound of more than one note. We're going to call each one of those a turn, and we're going to see how many. If let's say, for instance, we play 4 or 5 notes, we're going to see how many did the user get correct, and then divide those by the number of turns, and then maybe multiply by 100 to get a percentage. So that's a research to do. So based on the research, what is the specific scope for the application that we are going to build? Here I'm going to create a game for users to recognize different music notes played by a guitar. So I have a colleague of mine who played those notes on a guitar, and we're gonna use those files and these sounds and create a game for the user. So the third thing in problem formulation is testing. There are several testing scenarios. In a game, there are different features here, and as we will see, and different states of a game. So we're gonna start a game, play around with a correct answer, observe the score. So here we're testing the score, but there are different screens, and you will want to look at the different screens and test all the different screens. We're going to test correct answers, different incorrect answers, and test a mix of correct answer and incorrect answers, and so on. So to the solution formulation. The solution formulation is 3 parts. We follow a design pattern called the model view controller design pattern. So we ask ourselves first about the model, which presents the data, what data the app will need, and how to present this data to the user. So we have here the data are to get the data. You want to look at the problem statement or the scope and identify the nouns in the scope or the problem statement. These are candidates for data. So we talked about music notes. So an individual music note, that's a sound of a sound, and we're gonna have that sound saved as a file, as an MP3 file. So that's the data. How are we going to present that MP3 file in the app? We're gonna use a library class called AV Audio Player, and the AV Audio Player is part of a framework called AV Foundation, and this is the first time we get introduced to the AV Audio Player. So you may take few moments now to open the API documentation and learn a little bit about the AV Audio Player, or we're gonna do that as we proceed, and as we did in previous module, we're gonna open up the API documentation and keep going back and forth to learn about the different attributes and behavior of the library components that we are using. We don't have one music note, we have a collection of music notes. So again, we're going to need to represent a collection. So we're going to use the NS array. And we have the name of a single note. Why do I need the name of the single note? Because that's how I'm going to evaluate. So that's going to be a string. This will mean like the name of the note is A or A sharp and so on. The score, which will be a number, a decimal number, so it's float. We're going to need to have the number of turns, which will be a non-decimal number, a 3, 4, 5, how many turns will be in a game, and the number of correct answers, and that will be also a non-decimal number, so we're going to use the type int. Int is for integer, which is a non-decimal number. Again, as the note at the end here tells you, whenever we introduce a new API library or a library from the iOS, a class or a component from the iOS library, make sure you check out the API documentation to learn more about it. The view, what the user will see, and how the user will interact with it. In the past, I mentioned you would want to sketch what the app will look like and see it. Here, I'm going to be introducing you to a tool called mybalsamic.com, and that's a tool to create a sketch of the user interface or a mockup. There are several other tools as well. So I created this and have and export it to a PDF, which is what you see. So the game, I'm gonna design the layout of the game to have three components. There is the game itself, which is the screen that you see in front of you. Then there's a help screen, and there is a statistics screen that tells the user information about the game. So between the game screen and I have a button to go to the help screen and a button to go to the statistics screen. Then within the game itself, there are different states of a game. So the user will click this button to start a game. And once the user starts a game, we'll start counting the turns and the user will hear a sound. Then when the user hears the sounds, these buttons will be activated and the user will make a selection by clicking on a button. So in this state, the user made a selection which was correct. So the game will take the name of the note, compare it with the name that was played, and then determine if it is a correct answer. Tells the user in a label, send a message that this is a correct answer, gives the user an image to reflect that this is a correct answer, and tells the user where they are, progress indicator. We are at the third turn out of 10 or the third attempt out of 10. There's another state with the user selected an answer that was incorrect. So this is the incorrect state. In this case, the same labels will appear, but instead of correct answer, it will be incorrect answer. There's another image that reflects incorrect answer, and the turns are being displayed as well. And then the third state of a game, or the fourth state, because we have the state before the game starts, the game will be over, and in this case will display a dialogue or an alert that will tell the user the game is over, here is your score, and then the user will dismiss that alert and go back to the initial screen. So this is the initial screen or the game before it starts. Then this is a play game with a correct answer, a play game with incorrect answer, and this is an end of the game. At any time, the user can click the help screen to open a help screen that will have a label with instructions on how to play a game, as well as some buttons to practice the sound of the different notes. So this is a practice part. So the user click the A to hear what the A note will look like. So the user can come in the help and practice as much as they want before going back and playing a game. And in the statistics, will provide the user with some information about the game. For instance, the highest score, the lowest score, how many games have been played so far, and the current score of the game. So this is a sketch, a layout of the game. This is very detailed. We are still in iteration 1. So I have done this before, so it is fully mature user interface mockup. But in the beginning, you will not have that level of maturity and knowledge of what you want the app to look like and interact with. So as we discussed before, you answer as much as you know and trust that the iterative process will help you reach the conclusion. So in the beginning, at least I know I have a main screen, which will be the game screen. I have a help screen and a statistics screen. The third part is the controller. The controller answers questions what the app should do, when the app should do it, and what events should trigger the app to functions, which is the second and the third are similar. But the timing or the event is important because app development is what we call event driven. So the app will open and stay there idle until an event triggers the app. There are some built-in events like the view did load, parts of the life cycle of the different components in the user interface, and there are user-driven events where the user clicks a button, swipes the screen, touches, and so on and so forth. So what does the app need to do? And I described that a little bit when I walked you through the mockup. So we have three screens. Since each screen has its own logic and its own functionality, each screen needs its own independent controller. So we're going to have a game screen that's responsible for managing the game life cycle, starting game, playing game, and ending the game. We have a help screen that is responsible for displaying instructions to the user about how to play the game, and also train the user on what the notes sound like. And then finally, statistics screen, which is responsible for displaying the most recent statistics on the game. And how are we gonna go about all of those? We will explore this at in the different iterations. So the last step is the solution implementation. At this initial step, all right, how are we going to go about building this? What's our plan? We follow what we call iterative development life cycle. In iterative development life cycle, we divide the project into smaller projects. We call them iteration. Every iteration has a scope. Every iteration will have its own action plan. The idea is every iteration will produce a working app that we can discuss and show to our clients and view our progress, and then modify and improve as we move into the next iteration. This is another design decision, so everyone will break down the project into different set of iterations. In my style here, our first iteration is the one that we're about to finish. This is the planning and project setup iteration. It's usually done in the project kickoff. Then you have iteration 2. So what are you gonna go about building? And here I'm saying I'm gonna build, my approach is to build with the easiest. So what is the easiest thing? What are the things that I already know how to do, or at least I know most of it? So I found the help screen to be a very probably something we can start with. It only has a label. As you've seen, it has a label and it has some buttons. So we have done that. We used buttons before, we used the labels before. There's one thing on the help screen that is new, which is playing a sound. So having one new thing is good, but learning about playing a sound here is very important, because once we get to the game screen, we need to learn to play plenty of sounds. So I'm gonna do the help screen first, then move on to the game setup. So the game has different states: starting the game, playing the game, which has presenting the challenge to the user, collecting the user feedback, evaluating the user answer. And so we're gonna start with the game and present the challenge to the game by playing a note, and then either in that iteration or the next iteration collect the user response and then make a simple evaluation. Then this game is gonna continue with us in the following iteration 4, and we're gonna continue evaluating the user and displaying the end of the game. And then iteration 5, we're going to focus on calculating the score and updating the statistics. And finally, iteration 6, which is additional, optional, or extra credit. It will be some enhancements, enabling and disabling the user interface and adding different features to enhance the game. So this is my iteration plan, 6 iterations. In real life, you blend these iterations, and actually here, because you have about, I allocate about 3 weeks for this project. So you want to say, okay, I'm gonna spend maybe 3 weeks. That's 21 days, and I have 6 iterations. So perhaps I'll do, every iteration takes about 3 days. Um, and you blend that and you work on it this way. Sometimes the iterations will be in hours if it's a small project, in days, or sometimes in weeks. You don't want the iteration to be too long because it will defeat the purpose. The idea of an iteration is that you quickly get part of the project in a working condition that you can test, and you can learn more about the context and the app you're trying to build. So, and also you don't want it to be too trivial that it doesn't mean anything. You want to make each iteration to be meaningful, and each iteration to be complete. So that's our solution plan, and we first gonna go and set up the project, and I will do the project setup in a separate video because we have multiple screens, so that will take considerable. It will take more time than usual in the project setup. So that concludes iteration number 1 after the project setup. So we'll do that and then come back and continue the different projects, the different iterations.